this video, we are learning about chiral centers. And what is a chiral center? Well, it's just an sp3 carbon with 4 different things attached to it. Now, chiral centers are really important in biology and life. We are made of chiral centers. In fact, your hands are chiral. So your hands are mirror images of each other. And you can tell that because if you place them over top of each other, they line up. Now, your hands are not superimposable, and that just means that if I were to place them on top of each other, they don't align. Chiral centers are the same way. They are mirror images. However, if I just put them on top of each other, they are not in line, okay? We're gonna go through some examples in this video, and we are going to learn this R or S naming. Chiral centers can be either R or S, and it's really important that we understand how to name them so we can communicate when we talk about our structures. Now, many times in organic chemistry, we'll run a reaction and we won't get just one product. Many times we could get 2 chiral products, okay? We're gonna talk more about the relationship of these, but I just wanna highlight why this is important. Here I have 2-bromobutane. Here we have a methyl, okay, and then we have an ethyl group. Oops. This carbon center here has 4 different things attached to it. It has a bromine, it has a methyl group right here, and it has this ethyl group, and we're not drawing it in, but there's a hydrogen there. These 4 different things attached to it can be spatially oriented differently. Now, we could have the bromine coming forward, and we could also have the bromine going back in this dash. You could also draw in your hydrogens if you'd like. These 2 molecules, so here is our chiral center right here, okay? We're going to talk about how to name these, either with the R or S nomenclature. The reason I bring this up is because we actually know how to make this from 1-butene. We can do an addition reaction with HBr. This forms 2 molecules, 2 different molecules here. Now, these 2 compounds only differ in their chiral center. One is R and one is S. So we use R or S to name chiral centers. Chiral centers have 4 different groups attached to an sp3 carbon. Let's just review the mechanism for fun. Let's do that. So we've got HBr. We are going to protonate our alkene here with HBr. We're going to make our hydrogen adding to the carbon with the most hydrogens. That's Markovnikov addition. That means we have a carbocation here on this secondary carbon. All right, our hydrogen was added here. Okay, there is a hydrogen here also on this secondary carbon. So we've got a methyl, an ethyl, and a hydrogen on this carbocation. I'm going to draw this flat, and I'm going to show you that this carbocation, again, is in this p orbital. So I'm going to use ET for ethyl. Okay, so here's my ethyl group. So ET bounded this carbon, okay, and I'm going to put this methyl back, and we're going to bring this hydrogen forward. So essentially, I've drawn it flat on the paper, and then I rotated it, okay? Our empty p orbital, okay, can be attacked with this bromine. And it can attack from either the top or it can attack from the bottom. We get the bromine that's either wedged or it's dashed. Now, the chances of this bromine attacking this carbocation from above or below has the same probability. That means we're going to get a 50-50 mixture. Now, as we start to learn more reactions in organic chemistry, we're going to constantly come back to this idea about a chiral center. And is one made? One thing you'll note is that this carbocation doesn't have a chiral center because there's only 3 things attached to it. But it's this attack from the bromine, if it's attacking from the top or bottom, that gives us these 2 spatially different compounds. All right? So in this video, we're going to learn how to name them. And then later on in the course, we're going to be using this concept again and again and again. Well, how do we determine R and S? And we're actually going to use our hands to do this. The chiral pieces of our body that we have, right? So I guess you could use your feet too, but that would be really complicated. What we're going to do is we're going to label the 4 groups that are attached to our carbon center that I've circled here in red. These are our carbon chiral centers. We're going to number them 1, 2, 3, 4. We're going to use the same Kohn-Ingold-Prelog system that we use for alkenes.
Rules that I have listed below. I say that the highest atomic number is the highest priority.
The highest atomic number is the highest priority.
Once you've labeled your priorities, you're going to take your thumb and you're going to put it where number 4 is at. It's going straight up here. It's straight up in a line. So we're going to put our thumb up. Okay, doesn't matter which way you do it. You could go out to the side or forward. And you're going to rotate your fingers and you're going to look to see which of these and what order these are going in. Now, if we start here on the right, you're going to see that the order goes, well, the way the hand is drawn, it's like this, okay? Thumb up. We're going to rotate our fingers and you'll see that we go 1. We're going to go from 1 to 2 to 3, okay? 1 to 2 to 3. So as we rotate our fingers, we're going 1 to 2 to 3. We're using our right hand. That means that this is an R stereocenter. Now let's do the one here on the left. I don't know why I always start with things on the right side. I'm right hand dominant. So thumb is number 4, lowest priority group. Remember, this is atomic number, lowest atomic number. So that would be 4, okay? Then we're going to rotate our fingers. As I rotate, and the way the picture is drawn, it's drawn this way, but you can also go this way and kind of see it too. As I'm rotating, it makes sense that I'm going to be going 1 to 2 to 3. See how we're rotating there, and it works with our left hand, okay? So this is this hand rule for chirality. If you can use your left hand and be able to count 1 to 2 to 3, okay, then that means S. This is what we're going to use to do this. And you're going to start to feel crazy as we start to do this together. We're going to go over some problems, and that's the point, okay? That way no one bugs you when you're studying. Okay. Let's do a practice problem together. Okay, first things first, does it have a chiral center? And how do you tell this? Well, does it have 4 different groups on the same carbon? In this case, it's a yes. All right, we've got a hydrogen, a chlorine, a bromine, and a methyl. Great, we've got 4 different things. And then the second thing you need to do is assign priorities. One through 4. All right, let's do that. So of the 4 groups, which one has the lowest atomic number? That would be our 4. Well, if you said this hydrogen, you would be right. So there's 4. What about the highest priority? Which one has the highest atomic number? That would be bromine. Okay, and you can use your periodic table to help you. Chlorine would be 2, and then this methyl here, which has a carbon, would be 3. Okay, so we've done that. And then the third thing is to determine RS by using left or right hand. And I'm going to write test both. You might have to test both of them in order to do this. All right, so we've got our hydrogen in the going up in the line. So here's my thumb. All right, here's my hydrogen. And I'm going to use my right hand to start. Now, if I do this, when I'm starting this, the way that I have my right hand now, I'm looking at my fingers at the 3 carbon, that 3 methyl, okay? So I'm going to write R, and I'm going to say it starts at 3. I rotate. I'm going to hit number 1. There's the bromine. I keep rotating my fingers. So now they're all the way to my palm, and then I would hit 2. And if I could magically contort my hand to keep rotating, it would hit 3 again, right? So we're looking at it rotating around this way, okay? So then it would hit 3 again. All right, well, that's cool. Let's try out, though, what happens with the left. And then we're going to compare them. Let's use our left hand. Proton here is number 4 going up, okay? So if my left hand starts maybe at the chlorine there, at the 2, okay, then it hits bromine. I'm rotating, I'm coming towards me where the bromine is. That would be 1, okay? And then I'm going to hit the methyl. Now, if I can contort my hand to keep going in this circle, now we're going this way. I would hit 2 and then 1. You can keep kind of going through this in your head, and you can keep going through this in your head to see how it's going. You're trying to go 1, 2, 3, like a normal person would count. So you can see on the left side, it goes 3, 2, 1. We're going opposite. On the right, when we use our right hand, hydrogen going up, start at the methyl, 3. We go to the bromine, 1, okay? Hit the chlorine, 2. We end up getting 1, 2, 3. Hey, Rhodey. Okay, Rhodey wanted to help. My camera is opposite, so I'm going to re-record this. So the thumb is the proton. My fingers are where the methyl is at. It's going to the left, right? So then if I rotate my fingers, I'm going to hit the wedge, and the wedge is bromine. So it goes 3 on the methyl, bromine, which is 1. If I keep rotating my fingers, I would go back to the chlorine. All right. And then so you're thinking about how your fingers are rotating and looking at the number count. And that tells you, depending on which hand that works with, to go 1, 2, 3, what it is. So for the right hand, methyl fingers, move the fingers forward. You hit the bromine. That's right, Rhodey. Move your fingers more. You'll hit the chlorine. So sorry, my video looks opposite because I'm looking at my own hand. So here's a picture of what you can be doing with your hand. So make sure that you're doing this with me. It'll make a lot more sense. And you can always go back to the slide before where I have the picture of the hand, which might make sense, right? Yeah. You can use both hands to make sure that your assignment is correct. This molecule here has an R stereocenter. That's because when we use our right hand, the rotation with our fingers, when we curl them, is going 1, 2, 3, all right? This is again coming from the Cahn-Ingold-Prelog system for priority. So we have 3 steps here. Number 1, does it have a chiral center? Does it have 4 different things attached to it? Then, if you say yes, you assign the priorities, the 4 different groups on that carbon, 1, 2, 3, 4. You find the lowest priority group, and that's where your thumb's at. And you're going to be curling your fingers to see which, either right for R or your left hand for S, completes 1, 2, 3 in your rotation. It's okay if you have to start at a different number. You're just seeing if, as it keeps rotating, if it's going to end up going. So it really doesn't matter where that lowest priority group is because we're using our thumb. So we could rotate our hand pretty easily in order to test if this compound has an R or an S stereocenter. So let's look at this example here. I've listed 1, 2, 3, 4 instead of putting in groups. So on the top right of this slide, we have a left and a right hand, and we're looking here about how we're going to rotate it. So on the left structure, okay, I've got my 4 group going behind the paper. So I'm going to use my thumb. I'm going towards you, but it's behind the paper. What you're going to do now is you're going to rotate your left hand. Okay, and as I rotate my left hand, I see that I'm going to hit 2, first, then I hit 3, okay? And as I keep rotating with my left hand, okay, I'm going to hit 1. And if I could keep rotating, I'd hit 2 and 3 again. Cool. So that's giving me that S stereo center using my left hand. Now, if I look at the mirror image of this molecule, then we should be able to use our right hand to, again, locate the 1, 2, 3 using our fingers as we curl. So we're going to put our 4 group, which is our thumb. It's dashed. It's going through the paper. My fingers are going to curl to the right. That's just because I'm a right hand. It's a right hand, right? So we're going to curl our fingers. And as I curl, I hit 2. Okay, I'm curling this way. 2, 3, keep curling 1. So 2, 3, 1. And if I could magically keep curling my fingers and keep following this arrow, I'm going to hit 2. Okay, and then I'm going to hit 3. Notice here I end up getting that 1, 2, 3. So you're really looking at the overall rotation of your fingers as you're going through this. Again, it doesn't matter how these things are rotated. And we're going to do a realistic molecule now rather than this 1, 2, 3. So number 1, does it have a chiral center? Is there a carbon with 4 different things attached to it? Right here. Bingo. Number 2, so it has a chiral center. So 2, we're going to assign the priorities of the 4 different groups. Anytime you have a hydrogen, that's usually going to be 4. Always going to be 4. Okay, so that's 4. Cool. What about everything else? I usually like to go 4 and then I try to find the one that's number 1. So when I'm looking at these groups, we're going to use the same system we did for our alkenes. So each of these groups have a carbon attached to them, right? So they're all tied right now. So we need to go to the next step. On the methyl here, it's just a hydrogen, 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 okay? On this carbon here, we have an oxygen, oxygen, because there's 2 bonds to it, and a hydrogen. And then on this carbon here on the left, on this benzene ring, this carbon is bound to a carbon, carbon, carbon. So which of these 3 would win? Well, it is our aldehyde here. It has the 2 oxygens. This is the highest atomic number is coming up next. So this is going to be 1. This benzene group will be 2. And then our methyl with just the 3 hydrogens is going to be 3. So what we're going to do is we're going to take our thumb. We're going to place it where our hydrogen's at. It's dashed. It's going behind the paper. Okay, we're going to use both our right and left hands to figure out which one this is. So if I'm using my right hand and I start to rotate, okay, I might hit 3, 1, and 2. So I'm going to write that down. 3. So I'm using my right hand. Okay, so I'm going to be going this way. 3, 1, 2. If I can keep rotating, I'll hit 3 again. Cool. There's that 1, 2, 3. Very cool. So this is actually an R center. You can pause the video and prove to yourself that the left hand actually gives you the opposite. One thing I want to highlight is for the R centers, when you're using your right hand, you're always going clockwise. So right hand, you're going clockwise to get to 1, 2, 3. And for the left hand, you're going counterclockwise. To get to the 1, 2, 3, okay? Let's do one more example together, and why don't we throw in a more complicated structure, all right? This is Crestor. This is a cholesterol drug. So as you look at this, immediately you're like, this is not so. And what does she want me to do with that? I just want you to determine RS for any chiral centers that you can find. So are there any chiral centers? Well, are there any carbons with 4 things bound to them? All right, let's look. This carbon here kind of looks like it could be, but look, there's a methyl and a methyl. So negative, that is not a chiral center. What else do we have here that maybe has 4 different things? Well, it looks like there's some hydrogens that are not drawn in here. These 2 carbon groups are chiral centers. So let's determine RS for this big molecule, all right? So let's first do the one here on the left. Let's do this one. So as you're looking at it, this carbon has 4 different things bound to it. We know that it has a hydrogen, so I'm going to put a number 4 there. Okay, and this carbon also has an oxygen and a carbon and a carbon. Oxygen has a higher atomic number, so this would be 1. So the oxygen is going to be 1. The hydrogen will be 4. Now we're deciding between these 2 carbon groups. They're tied right now. They both have just hydrogens bound to them. So we need to now look at the next one, and I'm going to put a purple dot on this one. So on this next carbon, you see that we both have carbons, so we need to look at what's bound to it. So here we have an oxygen that's also bound to a carbon that's also bound to a hydrogen. So it would be OCH is here on the right side. And then this carboxylic acid derivative, we're going to look here. This carbon here, we would label it with an O because it has double bond to an oxygen, and it has one more oxygen there. Okay. This left side wins. Woo! That one was a struggle. Okay, I'm going to erase some of these extra hydrogens. We already know that those are CH2s and they line up. That means that this left side here is in fact a higher priority than the right. We've already labeled 1 and 4, so that would mean this side is 2 and this side is 3. Oh, buddy. Okay, so now that we have that, okay, we labeled our highest priorities, or we labeled our 4 priorities, and now we're going to take our thumb and we're going to put it where the proton is at. It's down, okay? It's down and going back. We're going to be using either our right or left hand to try to go 1, 2, 3, okay? Let's try our right hand here. Our proton is going down. If I start rotating my fingers, okay, I'm going to hit 2, 3, 1. So here I'm going to start rotating my right hand. So with my right hand, if I start rotating this, I'm going to go 2, then I'm going to hit the 3 priority. I keep rotating. I'm going to hit that oxygen and the OH group. 1. I keep going. Magically, I can keep rotating my fingers. My proton is going back in that dash. Keep rotating. I'm going to hit 3. 1, 2, 3. The right actually does work. Let's try the left hand just to confirm. Left hand, proton is going back behind the paper. Use your fingers and start to curl. You might find that you start at the 3, okay? Based on how your fingers are at, okay? 3, 2, keep curling. You're going to hit 1, then you're going to come back to 3. Notice how it's opposite, okay? It's opposite. If you are having a hard time seeing this in a 3D form, I do have this little QR code that you can pull up, and you can pull up this molecule and try and look at it with your hand in 3D form, okay? So I highly suggest doing that if you're having a hard time seeing it visually. I wouldn't expect for you to make this molecule in a model kit. That'd be huge. So in this case, because the right hand gave us the 1, 2, 3, this would be R. Do we have any more chiral centers? Well, we sure do. I'm going to circle this one in purple. We have another chiral center here, all right? So let's look at our OH group. We know this would be the highest priority. I'm going to go ahead and erase the highest priorities on this other side, all right? Just to give myself a little more room. As I'm looking at this, okay, we know that we have a proton here going back. So this would be 4, okay? I have a carbon and a carbon on either side. Now, as we look at the priorities, you are going to tell that the one on the right side has a double bond to a carbon, whereas the one on the left is just the CH2. So this side will be priority 2, and this side will be priority 3. Notice that when we assign priorities, we base it off of the chiral center we're looking at. So the carbon circled in purple, we're going to use our hands now to determine which handedness it has. Let's try our right hand first. So we've got our proton is going down and back into the paper because it's dashed. Your thumb is always number 4. I'm going to use my fingers here and I'm going to rotate. Okay, we're going clockwise. I'm going to hit 3 first. Then I keep rotating. I'm going to hit that 2 priority, which is that alkene. Okay, if I keep rotating, I'm going to hit the OH group, which is number 1. And you already see here we're going 3, 2, 1. We're going opposite, right? The right hand is not giving us the priorities in the correct order. At this point in time, you could just label it S and keep moving because you know that right hand doesn't work, but let's prove it to ourselves. We're going to use our left hand. Our thumb is the proton there. I'm going to rotate. My fingers are starting out at the 2 position right now. As I rotate, you're going to go 2, 3, 1. And if I can magically keep rotating, 2, 3, 1, then I would hit the 2 again. So on the left side, we go 2, 3, 1, 2. And if I could keep rotating, again, we're going counterclockwise here, then I would hit 3. So this side is in fact an S stereocenter. This is something that will take a lot of practice, all right? In this video, we looked at chiral centers. We learned what a chiral center is and how do we assign it R or S. In the next video, we're going to talk about not just one carbon and looking at RS. We're going to be talking about the molecule as a whole. We're going to use our naming system of R and S to help us describe the compound as a whole and then compare different molecules. This is very important as we start to learn more reactions in organic chemistry and how do we look at our products and describe their relationships. All right, I'll see you in the next video.